Continuing with the topic on thermochemistry or the energy and energy changes, you're going to get introduced to a new term called as enthalpy, that's delta H. So what is it? And there are you're going to basically learn about the heat at constant volume and at constant pressure. So let's go ahead and learn. We will first do heat at constant volume. So we know the equation internal energy equals Q plus W, where U is the internal energy, Q is the heat, and W is the work done. So when the volume is constant, delta V, the change in volume, will be equal to 0. So that means delta U equals Q. So at constant volume, the internal energy is equal to the heat, and we write it as QV. Now the next one, heat at constant pressure. Heat at constant pressure is given the special name delta H, and we call it as change in enthalpy. H is the enthalpy, delta H is the change in enthalpy. And that's defined as delta H equals delta U plus P delta V. So for the delta U over there, let's substitute Q plus negative P delta V, because that's the value of the internal energy. And you realize that both the P delta V's, they get cancelled, and what I get is delta H equals QP. Or I can say that the change in enthalpy is the heat released or absorbed, depending on the sign, at constant pressure. So it's quite common that chemists keep changing between heat and enthalpy, because most of the time they refer to a constant pressure condition. Now let us learn how the enthalpy of a reaction. Consider the reaction hydrogen plus iodine giving you HI, and the delta H for the reaction is given as 52.96 kilojoules. Now how does the enthalpy changes when I play around with this equation? For example, if I reverse the equation, like the equation now becomes 2HI giving you hydrogen plus iodine, then the value of delta H also reverses. So initially it was positive, and when I reverse it, it's becoming negative. That means when I reverse it, the heat is released, and the original equation, heat is absorbed. Then if I multiply the whole equation by 2, then the value of delta H is also multiplied by 2. And if I divide the equation by 2, so the whole equation is divided by 2, and the value of delta H is also divided by 2. For the given reaction, calculate the delta H is given. So you are asked to calculate delta H for another reaction. And if I compare the two reactions, the first one is C4H10, 13 oxygen giving you 8 carbon dioxide and 10 water. The second equation, if I compare it with the first one, you will see that it is divided by 2. So if delta H, if the equation is divided by 2, delta H should also be divided by 2. Therefore, delta H for this reaction will be negative 2.88 10 to the power of 3 kilojoules. Now the second one is, when I compare it with the given equation, the second one is it's multiplied by 2, and hence the value of delta H is also multiplied by 2. And the last one, and if I compare it, it has been reversed. So that means the value of delta H will also be reversed, and this becomes positive 5.76 times 10 to the power of 3. Now we are doing how the enthalpy changes in stoichiometric calculations. So calculate delta H for the formation of 3.35 moles of HCl according to the following equation. So the equation is given, and always check whether the equation is balanced, and the delta H for the reaction is given. So we know we have done such kind of questions in moles and grams. Similarly, they've asked for 3.35 moles of HCl. Start with 3.35 moles of HCl, and then from the equation you can see that 2 moles of HCl gives out a heat of 184.6 kilojoules. So convert that into the heat, and I get the answer as negative 309 kilojoules. The next one, in this case, we are asking you for the mass. Calculate the heat released when 15.2 grams of calcium oxide reacts with excess of carbon dioxide. Since excess is given, no need to calculate any limiting agent. And the equation given, calcium oxide plus carbon dioxide giving you calcium carbonate, it's already balanced, and the heat released is negative 178.4 kilojoules. So start with grams of calcium oxide, convert that into moles of calcium oxide using the molar mass of calcium oxide, then convert that into joules using the equation. Calculate the mass of sodium peroxide that releases the heat of 455 kilojoules. So we have just reversed the question here. The heat is given, they are asking you for the mass, and the equation is given to you, and you can see whether, just check up whether it is balanced before you start. Yes, it's balanced, and the delta H is also given. And since they are asking you for the mass, start with the heat which is given over there. Since they say the heat is released, it will be negative 455. Convert that into moles of sodium peroxide using the delta H value given in the equation. Then, once you know the moles of sodium peroxide, use molar mass of sodium peroxide and get the value of grams of sodium peroxide, Na2O2.